All right, guys, as we get into the next chapter, chapter 8, we are going to be focusing some time on polynomials. So today we're just going to identify what polynomials are, what monomials are, and then we're going to add and subtract these things. And remember that in algebra, we tend to add and subtract things that are like terms. Okay, so we're going to be identifying some like terms and then adding and subtracting. But first of all, polynomials. Poly meaning many. Many nomials. This is like many terms is another way you can think of this. But these are simply monomials or the sum of monomials. Now remember, I don't know if, I think we've talked about this before in the past, but a monomial is just a single term. And if it's a single term, you know, some people get confused here because they see things like 3xyz to the fourth, you know, and I ask them how many terms are there here, and people might count 1, 2, 3, 4, but that is not the case. This is an example right here that I gave you of a monomial. Mono meaning one, monomial, and the reason for that is monomials are typically separated, as long as there's no like terms, they're separated by plus and minus signs. So you're either adding or subtracting terms or pieces. This is all being multiplied together, so this all acts as one thing. If I said plus 3y or something like that, now we are into a binomial, bi meaning two, where we have two parts separated by this plus sign. And they are not like terms, even though there's a y in both. They're not like terms. The only thing I could factor out a 3y from both. Okay, and this is kind of going down a side street here, but then if you did that, you'd be left with 3xz to the fourth plus 1. Sorry, it wouldn't even be a 3, would it? Because the 3 came out. It would be xz to the fourth plus 1. Okay, so we still would have two pieces here. Anyway, so polynomial just means that we have more than one term. Okay, so and remember this, that negative exponents and variable exponents are not polynomials. If I had something like 2 to the x, that's not considered a monomial. Neither is x to the negative 3, for instance. Okay, so you can't have any variables in the denominator. X to the negative 3 is also written as 1 over x to the third, right? And we've identified these before, but I just wanted to remind you about that. Okay, so a binomial is the sum of two monomials. It is a type of polynomial with only two terms. Okay, so we have a special name for a two-termed polynomial. We call it a binomial. So here's some examples of that. One non-example would be something like this, that sometimes will throw people off. If I have 3x plus x, this appears to be a binomial because there's two pieces separated by a plus sign. But the fact of the matter is these are like terms, and so they could be simplified. 3x plus 1x is just 4x, right? So since it can be simplified to this, this is actually a monomial in disguise. And I just wanted to point that out. Okay, so binomials, it's the sum of two monomials. And just make sure that you can't have a combination like that. Okay, so this one and this one, the examples that I gave you, those can't be combined. Those are binomials. A trinomial, you can imagine what that means for those of you who rode tricycles as a kid or know about triangles. This is the sum of three monomials. Okay, tri meaning three. It is a polynomial with three terms. Okay, so notice here's an example, 2x plus 3y minus 1. Three terms separated by plus and minus signs. Okay, that's called a trinomial. Okay, guys, a couple more definitions for you. I know this is kind of a lot of definitions, but these are important. So the degree of a monomial is the sum of the exponents of all its variables. Okay, all of its variables, the sum of all the variable exponents in an individual term. This is of a monomial, so a single term. If there are no exponents, then we assume the degree is 1. Okay, and for every constant, we just we treat it as a degree 0, so we don't count the degrees of any numbers. This is just for variables. So for example, here we have 5x, y, z. So the x has a power of 1, the y has a power of 1, the z has a power of 1. If you add those together, you get 3. That is a degree 3 monomial. But so is this one. 6x to the third is also a degree 3 because it has a 3 here, right? It's like x times x times x. So that's degree 3 as well. And then I ask you here, what is the degree of this one? So I encourage you to do that one on your own. Let's take a look at it. This would be x to the third, so there's 3 there. Then we have 1 for the y, 1 for the p. So 3 plus 1 gives me 5. This is a degree 5 monomial. Now, you have to know that in order to find out what the degree of a polynomial is. And the reason that the degree of a polynomial is important is because that is how the graph will behave, which we will learn more about in Algebra 2. But for now, we just got to start getting you guys used to identifying some of these things. So the degree of a polynomial is the term that has the highest degree. So typically what we do is if we have a bunch of different things in a polynomial, we try to line it up so that we put it in order of the highest degree, so that we can talk about how the graph behaves by looking at the first term. So let's look here. They're not always going to do that, but that's what our job will be. So for this one, notice that the first term here, the first monomial, has a degree of 1, 2, 3, 4, 5, 6. This has a degree 6. The second term has a degree 3. And the third term doesn't have any variables, so we don't worry about it. So since this one here, the first one, has the most, or the largest degree, then we know that that is the degree of the polynomial. So this is a degree 6 polynomial. Okay. And then the second one, notice this one's not in order here. For the second one, this is degree 1 for this monomial. This one's degree 3 for this monomial. And so this one has a degree 3 because the highest one is actually the second term, and it has a degree of 3. So if I was going to write that second one in standard form, I'd want to put the degree 3 out first. So I'd say 4x, I just rearrange it, 4xyz plus 2u plus 9. Okay, now it's more in standard form. And the reason that I want it in standard form is so that the leading one here, when I look at it, the first thing that I see is the leading term, or how the graph's going to behave. Okay, so let's do an example. So example 1 says determine if each expression is a polynomial. If so, write the degree and whether it is a monomial, binomial, or trinomial. Okay, then I think I did the first one with you. So the first one's just the term x. So this is just one term, clearly, and it has a power of 1, even though you don't see it there. So this is it is a polynomial, even though it's kind of weird because poly means many. This only has 1, but this is a specific type called a monomial. So it's a degree 1 monomial. For B, let's look at that one real quick. We have this guy, and then notice here, these two pieces are like terms, so I can combine them. So I have negative 2y plus 4y gives me 2y. So notice how I rewrote that here. And now that I've simplified this by writing all my like terms together, now I can say something about this. Okay, so this is a trinomial. Okay, the reason is that we have 3 pieces to it. So it's a specific type of polynomial called a trinomial. And then the highest degree that I see here is the first term, and it's a degree of 2 because it has the exponent 2. So this is a trinomial degree 2. Okay, I would love for you to try out 1C on your own. Let's look at it. This one would be, so these are not like terms, so can't combine anything. This is degree 2. This is degree 3. So the polynomial as a whole, since there's only 2 terms, this is known as a binomial. And the degree is always the degree of the highest term. That would be this one. So this is degree 3. And then for our final one here, remember your definition of a polynomial. There are no negative exponents. And what do you see here? A negative exponent, so this is not a polynomial. Okay, this behaves much differently on a graph than the rest of them. Okay, so that's kind of the first part here. Then we have to talk about standard form and the leading coefficient, and then we will do a bunch of examples and be done. So here we go. Standard form just says, list the terms in order from the greatest to the least degree. I've already kind of mentioned this. So notice example 1 here. The biggest degree is actually the z term. It has a degree of 3. The y term has a degree 2. The x term is degree 1. So we rewrite it in order of degree so that the highest degree is first. So z to the third is first, then 3y squared, then 2x. Okay, so that's an example. And that first term there, whatever is out in front, whatever number is out in front of the first term, that is known as the leading coefficient. If you don't see a number, we can assume that it is always 1. All right, so let's take a look at that. This one here, they want to know what the leading coefficient is. So in order to do that, we put this in standard form. Oh, it's the same one. Perfect. Okay, so we put it in standard form, and then we look at the number out in front, and in this case, it is 1. Okay, so I'll do some more of these with you so that you get really comfortable with that term, leading coefficient. Let's look at this one. So for 2a, if we write this in standard form, this guy right here is the highest degree monomial. So that one comes first. Okay, and then followed by the 2, then the 1, then the 8, right? So the leading coefficient, this is a degree, just to be clear here, this is a degree 3, because I'll ask you for all of these things. This is degree 3 polynomial. It has a leading coefficient, which I just usually call the LC, of 4, because that is the number that is out front. Okay, so let's do another one. For the next one down here, notice that the first highest degree would be that guy. Okay, so let's write it. This would be negative 7y to the 6th. And then the next highest thing would be plus 5y to the 3rd. Then negative 2y squared. Then plus y plus 10. So I just rewrote it in order of degree. That helps me identify my leading coefficient. My leading coefficient in this case is this guy right here, negative 7. And this is a degree, just in case they ask you on the homework, degree 6. Because the highest term is 6, degree 6. Okay, to add and subtract polynomials, we have to, just like with fractions, just like some of these other things that we've been doing in algebra, we have to only add or subtract like terms. That means same variables, same degrees. Okay, same variables, same degrees. You might want to write that in your notes. So for example, we have this guy where we have this polynomial, and we add the two of them. We're going to just combine like terms. Okay, so when we do that, we look for things that are similar. This guy has an x squared on it, so does this guy. So if I combine those two things, I get negative 2x squared. Then if I have the positive 5x plus 6x, that's going to give me 11x. Negative 7 plus 3 gives me negative 4. So my answer here would be negative 2x squared plus 11x minus 4. And if they ask you more things like what's the leading coefficient? Leading coefficient now you should know is negative 2. The degree of this polynomial is 2. Okay, we should know all of that now. Let's add these two together. Okay, I'm going to do this one with you. You're going to do 3b on your own. Here we go. This one we have 5x squared minus 3x squared with a plus sign in between. So this becomes 5 plus negative 3, which is just 5 minus 3, which is 2x squared. Then I have negative 3x plus 6x, which would be plus 3x. And then I have 4 plus negative 3, which is just plus 1. Okay, and I think that's all they want you to do. They don't need you to do this, but the leading coefficient on this one would be 2. The degree on this one would be 2. Okay, try this one out, 3b on your own. Let's look at it. So we have y to the 4th plus negative y, 2y to the 4th. So that's like 1 plus negative 2, which would be negative 1, or just negative y to the fourth. Okay, we don't have to include the 1 there. Then notice this. There's nothing in here. This is an important one, actually, and probably would have been difficult to do on your own, so maybe I won't make you do this on your own. There's no y to the third terms over in this guy, but there is here. So it's like saying 0 plus 2y to the third, which would just be the 2y to the third. Okay, then we can combine, there's no y squared, so now we can go to this one. Negative 3 plus 2 is just going to be negative 1. Negative 1y. And now I'm done with that term. So I've done this one, I've done this one, I've done this one, I've done this one, I've done this one. I'm left with 7 plus negative 11. 7 minus 11 is negative 4. So for 3b, I get this guy. This has a leading coefficient of negative 1. This is a degree 4 polynomial. If you subtract, it's the exact same deal, except for you have to remember now, if you're subtracting, order is very important, and 2 negatives make a positive, right? So that's all that we really need to hit on. Let's go to this one. So we have 4x to the third minus negative 2x to the third. So that's 4x to the third plus 2x to the third, which would be 6x to the third. Okay, then that one's done. And then I have negative 3x squared minus, that applies every time, x squared, which would be negative 4x squared. Then that one's done. And then I have 6x minus 0, so that would just be plus 6x. That one's done. And then I have negative 4 minus negative 2, which is negative 4 plus 2, which is negative 2. Okay, so for this guy, leading coefficient 6, degree 3. Let's go to the next one, 4b. Okay, so now notice on this one, there's no y to the thirds in this guy, but there is here. So it's like saying 0 minus negative y to the third, which would be like 0 plus y to the third. Therefore, my y to the third is positive. All right, so just be careful on that one. For my next one here, let's go to the y squared term. So this one's gone. 5y squared minus no y squared would just be plus 5y squared. And then I have 8y minus 12y, which would be negative 4y. Sorry about that. And then I have negative 10 minus 7, which is negative 17. Okay. I think that is all we have for today. I know this is kind of a lot of information, but refer to the video often if you need to, and I'll answer questions in class. We'll see you guys next time.